Okay, hi guys. So in this lecture, we'll be talking about a new topic called migratory aptitude. So let me write down the heading first. This is called migratory aptitude. So in the previous lecture, in the pinnacle rearrangements and bringing expansions, we actually before that also we actually saw that we had CS3 minus shift or H minus shift. So in this uh, article, we are going to see means what how much the tendency of compounds to actually shift themselves from one attached carbon atom to another attached carbon atom. So we will be comparing some of the compounds on the basis of their migratory aptitude. Okay, so let us understand with this with the example. Suppose we have something like this, and we have CH2 with the positive charge attached. Okay, so what actually happens is this CS3 goes into the migratory phase, and this actually forms a positive charge intermediate, okay, before leaving this C and attaching to this C. Okay, so if you closely look into this is a aromatic intermediate. Why? I'm just talking about the ring. This ring is showing aromatic characters. How? This has a partial negative charge and these two are partial positive charge, so 2 pi lone pair are there. Okay, so this is showing a aromatic character. Okay, uh, that's why the CS3 shift is actually getting feasible uh, in this type of migration, CS3 minus shift. Okay, if you talk about this, okay, so if you talk about the shift of either this one or either this one, which one should be preferring? We would be preferring this one. Why? I'll just tell you the reason in the intermediate. Because when you look into this, let me redraw it. When you look into it, you will see that this bond breaking and bond formation is in place, and the structure is aromatic as well, and this CS3 is serving as a plus I effect to the positive bond which is circulating inside this ring. Okay, and this is also aromatic in nature, this ring formed. Hence this would be instead of 1 degree carbon migrating, 2 degree carbon migration would be seen. Okay, let us look at now. Let us compare actually the rate of migration or the migratory aptitude. So more the electron on density or electron density on the migrating group, more will be the its migratory aptitude. Okay, so if we compare the migratory aptitude of these compounds, we can actually say, or this has been experimentally verified, that the migratory aptitude among these compounds is of the order of um, Cl and OCS3. So the experimental facts which say something about them is the migratory aptitude is of the order of 500 is to 15 is to 1 is to 0.7 is to 0.3. The ortho substituted compounds are were verified to be having very less migratory aptitude because of well-known steric hindrance reasons. Okay, and we actually, if we compare the migratory aptitude among these compounds, which I'm just going to write, these are the highest migratory aptitude compounds. Then 3 degree carbon, 2 degree carbon, 1 degree carbon, and CH3. Okay, so this was the order which was found out. Okay, and why? Because obviously 3 degree, 2 degree, and 1 degree, obviously because of the minus I effect which they can bring into the table when they go into forming the intermediate of the migration, and obviously phenyl can bring into uh, uh, more electron density or more electron rich, maybe uh, can show my more minus M effect into the intermediate formed. Okay, and H is the highest because of means it is the least sterically hindered group among all these, hence H is uh, H is directly getting attached at the fastest rate and showing the highest migratory aptitude. Okay, so now let us take another point that when we actually try to migrate uh, in a carbanion, what actually happens is, can't we just migrate this carbanion into this, because it can have resonating structures and CS3 here. This reaction does not take place. Why? This step of shifting does not take place. Why? The reason is, when you draw the intermediate ring which is formed as a result of shifting is showing anti-aromatic characters. How? This would be getting partially negative charge, this would be getting partially negative charge, so total obviously 4 pi electrons, planar, cyclic, delocalized, hence it is showing anti-aromatic character, hence this reaction or shifting does not take place. Okay, this is an important fact. Many questions have been asked around this concept. Now let us see what happens in when two free radicals come in contact with each other. Then obviously a dimer is formed and activation energy for dimerization is 0. Okay, so let's write some notes on the above observations, which are that better electron donors have better migratory aptitude except ortho substituted ortho group, which we have seen that it was found out to be of the order of 0.3 in the last examples. So it's just writing it that better nucleophiles, better electron donor rather, has better migratory aptitude. Okay, except ortho substituted group. Okay, and second note is carbanion will not undergo dimerization because of shifting because of anti-aromatic transition states. Okay, so carbanion will not undergo shifting because of anti-aromatic transition state. Okay, and the last point is dimerization of free radical or free radicals rather have zero activation energy. Okay, so with this we come to an end of this lecture. In the next lectures we'll be talking about reaction of pinacoles with different reagents. Till then, good luck and goodbye.